Good morning to you all. I trust this video made you safe. Welcome to physics class. In today's class, we shall be looking at the topic work, energy, and power. We, we do work every day as human beings. Somebody going to the office is doing some amount of work. Right here before you, I am doing the teaching work. One who is engaged in thinking is doing work. But we don't want to look at work in that dimension. We want to look at the physical meaning of work. What physics has to say about work. Physics defines work as the product of force and the perpendicular distance. The product of force and the perpendicular distance in the direction of the force applied. Work is defined mathematically as W is equals to force times distance. Let's call this our equation number 1, where W is work and F is force, D displacement or distance. Work is measured in the units of joules. F is measured in the units of newtons, and then D the units of meters. So let's say work is joules, force is newton, and distance is meters. Recall from Newton's second law of motion, which states F is equals to ma, where m is the mass of the body and a is the acceleration. Substituting this variable into this equation, we'll have a new equation for work. W is equals to ma times distance. Call this your equation number 2. These two equations on the board are used to solve equations that has to do with work done on a linear surface where there's no inclination of any given angle. We'll be considering one good example that relates this equation. So let's say example number 1. A body is displaced through a certain distance x by a force of 30 newton. If the work done is 100 joules and the displacement is in the direction of the force, calculate the value of x. The value of x is simply the displacement or the distance covered by that body. So let's say from work, W is equals to force times distance. Mind you, D is a cultural symbol. Some textbooks use L for D and some textbooks use X. They all mean the same thing, provided they are measured in the same SI unit. So we are permitted to write X in this place. And so from the equation above, we are supposed to make X the subject of the formula. So we say X is equals to work done all over force. And so X is equals to the work done is 100 joules, and then the force is 30 newton. This go, and then you have 10 over 3, and our answer, therefore, X is equals to 3.33 meters. And that is the answer for that. We'll also consider example number 2. Calculate the work done by the first solution. Simple. So let's collect our data. The parameters involved in the calculation. One is force. F is equals to 40 Newton. Acceleration A is 0.1 meter per second square, and then the time T is equals to 4 seconds, and then the work done is not given, and of course distance is also absent in that equation. Now this is where physics calculation becomes difficult for novice in physics. I once told us in this class that for you to be able to have competence in calculating physical equations, you got to have a whole lot of equations upstairs. Now we are going to make use of one of the 3 equations of motion on a straight line. Probably equation number 2. Equation number 2 states, now using S is equals to ut plus half at squared. We have it that when the body was initially at rest, our initial velocity was 0, and so we have S is equals to 0 times t plus 1 over 2. Our acceleration is 0.1 times 4 squared. So this goes, you have S is equals to 1 over 2 times 0.1 times 16. So you have 0.1 times 16, 0.1 times 16 by 2. We have a distance as 0.8 meters. So distance S is 0.8 meters. That is not all. We're asked to calculate the work done. And so work done is given as what? W is equals to force times distance S. And so we have our force as 40 Newton times 0.8. Therefore, W is what? 0.8 times 40. We have 32 joules. So our work done is 32 joules. We want to look at this point. Work done under gravity. Work done under gravity, or work done under the influence of gravitational field. Example, climbing the staircase in your school mech is a practical example of work done under gravity. And also lifting the weight of load up. Now, I believe you know this. These are slotted mass. We have 1, 2, 3, 4, 5. 500 grams. And that is 0.5 kilogram. Now, let's suppose you lift this mass of body up this way to a height of 80 centimeter. Yeah, 80 centimeter. 80 centimeter is about what in meters? That is 80 by 100. You have 0.8. So 0.8 times 0.8 times 0.5 times. The value of acceleration due to gravity in this school is 9.8. So times 9.8. Let's write it down. The equation for work done under gravity is giving us W is equals to mgh. So we are saying if you lift this weight of body, this is 500 grams. Convert to kilogram, you have 0.5 kilograms. Lift it up to a height of, let's say, 80 centimeter, that is 0.8 meters, times the value of acceleration due to gravity in this school, that is 9.8. You have W is equals to 0.5 times 9.8 times 0.8. Our answer is 3.92 joules. So the work done under gravity by lifting this object up is giving us 3.92 joules. We shall be looking at the subtopic energy. We define energy as the ability to do work. Simple. So when you are hearing about interchangeability of energy and work, it simply explains how interwoven energy and work are. Energy and work are measured in the same SI unit of joules. If you don't have energy, you can't do work. Now let's look at forms of energy. There are various forms of energy. You have light energy, electrical energy, you have sound energy, you have chemical energy, you have wind energy, and you also have mechanical energy, etc. And for the sake of this class, we shall be concentrating on mechanical energy. What do you mean by mechanical energy? In physics, when we are talking about mechanical energy, we are simply referring to two forms of energy, namely potential energy and kinetic energy. Energy and kinetic energy. Potential energy is defined as that form of energy that is possessed by a body by virtue of its position. Simple. Every item you see on the table here possesses an amount of potential energy with reference to the height above the ground level. Potential energy, PE, is defined mathematically as mgh. Let's call this equation number 4. Let's look at kinetic energy, KE. Kinetic energy with the acronym KE is defined as the energy possessed by a body by virtue of its motion. So we can see that mathematically kinetic energy is given as half mv squared. Let's call this our equation number 5. Take notes. Potential energy, PE, depends on the height of an object and also the mass. While kinetic energy depends on the velocity of the moving object and also the mass. Meaning, if an object is not moving, there's no kinetic energy. If an object is not placed at a height above the ground level, there's no potential energy. Examples of potential energy include a mango fruit falling from the tree, a moving car, example of kinetic energy, and also the movement of gas molecules confined in a vessel are also good examples of kinetic energy. Let's look at some examples that has to do with this, so that we can solve them and have ourselves acquainted with how to use these equations. Let's look at example number 3. Example number 3. Example number 3. A 500 kilogram car which was initially at rest traveled with an acceleration of 5 meters per second. And its kinetic energy after 4 seconds is given as what? Simple. Let's collect our data. From the equation above, your mass M is given as 500 kilograms. And then your acceleration A is given to be 5 meters per second. And then your time T is given to be 4 seconds. Mind you, the velocity of the moving object is not given. So you have V is equals to question mark. So what do we do? Very simple. What do we do? I say it's very simple. Recall from the equations of motion that acceleration A is given as velocity over time. That is the rate of change of velocity with time. And so with this relationship, we'll be able to find our velocity for the moving object. So we have V is equals to A times T. And so by substituting the values here, we have A as 5 and T as 4. And so we have 20 meters per second squared. Therefore, your velocity is 20 meters per second. 20 meters per second, sorry. 20 meters per second. We now move to calculate the kinetic energy. And so we have kinetic energy K E is equals to half mv squared. By substitution, we have Ke is equals to half times 500. Half times 500 times 20 all squared. Half times 500 times 20 all squared. And so we have 500 by 2 times 20 squared will give you 400. Yeah, 400. So 500 by 2, you have 250 times 400. 250 times 400. So what will be our final answer? Our final answer definitely is 100,000 joules. So we have 100,000 joules. Writing this answer in the standard form, we have 1. We have therefore our Ke is equal to 1.0 exponential 6 joules. 1, 2, 3, 4, 5. Yeah, exponential 5 joules. So our kinetic energy is this. Very simple. Look at example number 2 and then we'll wrap it up for this section of the class. Example number 4. Example number 4. So let's have example number 4. A body of mass 5 kilograms fall from a height of 10 meters above the ground. What is the kinetic energy of the body just before it strikes the ground? Neglecting energy lost, take G to be that. Recall that we have to take our data collection. Data collection is 10 meters per second. And so we are going to use two basic equations here. One, we have from the third law and from the third equation of motion, you have it that your V square is equals to U square plus 2GH. This is for equation of motion under gravity. I told you the meaning of this in our previous lessons. And so the body was initially at rest, meaning our initial velocity was 0. And so we have V square is equals to 0 square plus 2 times 10 times 2 times 10 times 10 times this, you have 200. So your V is equal to the root of 200. What do you have? You have 14.142 meter per second. But that is not all. We're asked to find the kinetic energy. So this is our velocity. So KE is equal to half mv squared. So you have half times 5 times v squared times 14. Let's put it 14 squared. So what do you have? You have 80 over 2, and so our kinetic energy, therefore our KE is equal to 490 joules. With this we come to the end of this lesson. I advise you to take time to pause this video intermittently and jot down the important points. I'm also giving you some exercise to do the note I released to you. Thank you, and remain blessed, and God bless you all. Thank you.